Okay, let's talk about torque. Torque is a twisting force. If force is simply a push or pull, then torque in a simple sense is just a twisting force, a twist. And let's start with a simple example. A nut that we want to loosen with a wrench. And so let's apply a force. Let's apply 6 or 8 forces. Let's apply a force here of 100 units, a force here of 60 units, a force here. This is not going to be to scale, but let's say it's 20 units. A force here of 50 units. A force here of 50 units. And a force in this direction of 100 units. Let's see if I can put this to scale. So that's 20. The 50s look good. Let's make the 60 a little bigger than the 50. Whoops. $20, $50, $60. And the hundreds need to be quite a bit bigger than that. So okay. So let's call this A, B, C, D, E, and F. And I want you to rank these according to the twist, how much twist they're going to give. Which torque is most likely to loosen the bolt, or actually tighten the bolt in the direction we're going. So pause the video and rank from smallest to largest torque. Okay, here's my ranking. So what did you think about? You should have thought about 3 things. Here's the torque equation. So for any situation, the twisting force or the torque will be equal to the distance. Let me go back to this. Let's look at this. The distance where the force is applied from the axis of rotation. So this is rotating about here. And so A is the biggest force, but it's close to the axis of rotation. C is the smallest force, but it's far away. So which one is going to give you more torque? There's a little bit of guesswork here because I didn't give you the distances. Also, if there's an angle, like if we take, here's a force of 100, right? Same magnitude as this one, but it's at an angle. Well, I don't know that angle, but I can see that this force F has a perpendicular component and a parallel component. And the parallel component, I'm talking about parallel to the wrench, the parallel component doesn't do any torque. It's along the axis, like this force D, doesn't cause any torque. So it's the magnitude of the force the distance of the force from the axis and the angle at which it operates. And so this is what the equation looks like. If we go to the equation for torque, we see that we have to take into account the distance from where the force is applied to the axis of rotation, the magnitude of the force that's applied, and the angle. What's important about the angle? We want it to be perpendicular. So in the torque equation, we want to take the sine, the sine of the angle between the r vector and the f vector. So the angle between the r and the f. So in this case, here's the r, the distance from the axis to where the force is applied. Here's the f, and so this would be the angle theta for this. And in this case, we have our r and our f. So I'm going to slide the r this way. And so in this case, this would be the angle that we care about. This would be the angle theta. Whoops, can't see that. But that's the angle theta that we would use to calculate the torque. And we want the angle to be as close to 90 degrees as possible. So with this in mind, this is how I came up with my ranking. Kind of guessed. I see that D is obviously has a torque of 0. No matter how hard you push, and no matter how far away you are, if the angle is 0 degrees or 180 degrees, then the sine of 0, 180 is 0. In other words, if I push or pull along the axis of the wrench, it's not going to cause any twisting at all. Okay, so this is 20 and this is 100, so I got to look at these distances. So I see that, well, I'm looking for the small. So this force is 20. This is about, I'm guessing, is about half of the 50. So this force here is just a little bit bigger than the 20, but it's way back here on the wrench. So I guessed E as the smallest torque, the least amount of twisting. Then I went to A. Now, why did I pick A as being less than C? Well, I was kind of guessing. Is this distance, this is 5 times smaller, and I'm guessing this distance is more than 5 times bigger. So I picked this. But these two are actually going to be pretty close. In other words, here you got a big force but a small distance. Here you got a small force but a big distance. So you might have put these in the opposite order. I wouldn't argue with you. And F is a big force, but out of the 100 units, so the perpendicular part of this force, let's say it's 50 units, and here we have 60 units, so this is 60 units further away. I'm saying B is going to be F, so I rank them in that order. Okay, now let's actually take this equation and calculate what the torques are. Of course, to do that, I've got to give you some information. So here's the information you're going to use. Take these two angles, theta 1 and theta 2. Let me write this down. We'll call this 1, we'll call this 2. You're not going to be able to read that, but theta 1 equals theta 2 equals 30 degrees. And then the distances, we'll call it RA, RB, RC. Let me write those. I'm going to pause the video and write those down just to save some time and then come back. Okay, I'm calling the wrench from the center to the edge, 50 centimeters. And so I have D and C both at 50 centimeters. That doesn't look exact, but close enough. And E right here, a little more than halfway, so that's 30 centimeters. And then B, about 2/5 of the way, so that's 20 centimeters. And A at 10 centimeters, and F halfway between at 15 centimeters. So these are all in centimeters. These angles are in degrees. And the 100, 60, 20, 50, 50, 100, this is 100 by the way, it doesn't look like it. Those are all in newtons of force. So now I want you to calculate all the torques. So you're going to do torque A, torque B, torque C, torque D, torque E, and torque F. So calculate all 6 of those, write them down, and then come back and check in. Okay, I hope you did the calculations. So here we go. I changed all these to meters because the preferred units for torque are Newton meters, but if you didn't, you can just multiply by 100 and you should get all the same values. So this was 0.5, 0.3, 0.1, etc. So I came up with a value of, for A, 10 Newton meters, B, 12 Newton meters. Notice the units of torque are Newton meters. And although that's the same as a joule, we don't write it as a joule because it's not an energy, it's a torque. C was also 10 Newton meters. D was 0 because of the sine of 0. And E and F both turned out to be 7.5 Newton meters, and you're not seeing the units because I went off the page. So you see my rankings were, the one that's wrong is F. F is actually less than A and C and should be in the 3rd position with E. So E and F are the same torque, A and C are the same torque, and B is the largest. A and C come next, then F and E, and then D is 0. And so that concludes our study of torque.